Hi, I'm Liang Yu. Today, I would like to talk about the in ovo nutrient administration and apical owl entry model in chicken. We know intestinal development involves differentiation, proliferation, and functional maturation. In neonatal stage, the nutrient is crucial for the intestinal development because we believe in that period the stem cell is more trainable and can be destined the phenotype to their later life. To become more mature intestine, or like say the functional epitheliums, the stem cells must to be differentiated into a different type of epitheliums. For example, differentiate into the enterocytes, which is responsible for the absorptions. So right now we know the functional change is associated with the development of the intestine. Then how we test the functional change of epitheliums? We choose apical owl entries as our model to quantify the functional change of epithelium. Entry is a mini gut in the culture dish which isolated from animals' intestine. Not like the basal owl entries, the lumen of apical owl entry is facing outside, which is easier for us to test the function. Then how about the nutrients administration? We chose glutamine as our treatment because previous studies show the beneficial effect in intestinal with the glutamine treatment. However, we still don't know how the glutamine affects the intestinal functions, and we don't know how glutamine affects the intestinal epithelium populations. We hypothesize that in ovo glutamine administration increase the epithelium's functions, which indicating more mature intestine. Further, the in ovo injection of glutamine alters the epithelium's population. To prove the hypothesis, we designed the following experiments. First, we inject 200 microliter of PBS or 3% glutamine into the egg yolk. We euthanize the animals and harvest the intestine on day of hatch. Second, we isolate the apical owl entries and culture for 4 days. After 4 days, we perform multiple functional assays in the apical owl entries. And then we use ileum samples to test the epithelium population change. Finally, we use the messenger RNA expression to indicate the difference between tissue and entry samples. With our results, we found that the intestine length significantly increased in ovo glutamine treatment group, which indicating more mature intestine. Next, we quantify the intestinal morphology and epithelium's populations. So we found the glutamine treatment significantly increased the villus height and decreased the crypt depth, which also indicating more development intestine. For the epithelium population, penny cells significant decrease, which might indicating the decreasing of supporting to stem cells reflect to the decreasing of the crypt depth. Endoendocrine cells and goblet cells significant increase, which might indicating the more mature intestinal functions. We use apical owl entry to test the intestinal functions. First, we test the proliferation. We found the glutamine injections significantly increase the EDU fluorescence, which indicating the increasing of proliferation. The proliferation gene expression marker, pCNA, also significant increase in glutamine treatment group. Further, the differentiation marker, HIS1 and DI1, significant increase in ovo injection group. Next, we tested permeability and absorptions in apical owl entries. Our data show the significant decrease in physidiatrin FD4 leak-in entries, which suggesting the in ovo glutamine injection groups has higher barrier function. Moreover, glutamine injection significantly increase the absorption of glucose and the nutrient transporters messenger RNA expression. Overall, our data suggests that embryo 18 in ovo glutamine injection enhance the maturation of intestinal development in day of hatch chickens. Therefore, we show that the early life nutrient administration can increase the intestinal development, which benefits to chickens to be ready for faster growing in their later life. We also demonstrate a novel way to quantify the intestinal functions, which will be great tools to quantify the supplemental products or other treatments, since it's easier to do and you can directly treat in the cultural media. Moreover, the current apical owl entries functional analysis is more accurate than the cellulized model because they contain more type of epitheliums. Thank you for your attention. Meet me on November 16th for more details and questions, and looking forward to seeing you in the symposium. Bye.